types of persistent labels are there? How many types of persistent labels? Persistent labels, right? How many persistent labels are there? When we are using persist function, there are 5 persistent labels are there, right? Okay. Memory only, disk only, memory and disk, memory disk serialization. So these are the persistent labels. What is the difference between the group by key and reduce by key? Anybody knows group by key and reduce by key? Both are transformation. Both are doing the same thing, aggregation based on the key. But there is a difference in group by key and reduce by key.
Is that the shuffling? Shuffling is the difference?
Yeah, shuffling, based on shuffling, there is a difference. So
yeah, across different levels. Group by and reduce by is the local, right?
Yeah, reduce by key is doing shuffling after the aggregation, right? Aggregation is first. Okay, aggregation first, then shuffling happens. So less data travel over the network in case of reduce by key. But in case of group by key, the 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 shuffling is like first, right? So more data will travel over the network. So group by key is expensive than the reduce by key.
Yep.
Okay. So group by key is more costlier and reduce by key is not costlier. Okay. What is the difference between the wide transformation and narrow transformation?
Narrow transformation doesn't require the data to be shuffled across the partition, and wide transformation requires the data to be shuffled. For example, reduce by key.
What are the examples for the wide transformation?
Reduce by key.
And narrow transformation?
Map filter and flat map.
Filter.
Yeah.
These are the narrow transformation. Okay. And can you give anyone examples of 5 transformation and 5 actions? Any 5 transformation and 5 actions? There are so many transformation, right? Map, flat map, filter, join, group by key, reduce by key, union, right? And actions?
Show, collect.
Show, collect. Count.
Yeah.
Sorry.
Count.
Isn't reduce is also action, I believe. Reduce. Reduce.
Reduce is action. That is doing aggregation like sum, right? If you want to result.
Yep.
Okay.
Take top. Yep.
Take is also action. Take order. Okay, so that is also action. So these are the action which is giving the. So what is the difference between the transformation and action? Like we say this is transformation, this is action. So what is the main difference in transformation and action?
One is lazy evaluation. One is fast. The action is the fast implementation execution, where you have to.
Lazy. That is the answer. Transformation is lazy and action is fast. That's the answer.
Yes, but I was gonna just explain how it works. Like in the lazy transformation, it doesn't do the actual. No, it doesn't do the actual work. It will just do the transformation in memory. It will keep it there until you call an action on it.
Okay. You mean to say when you call action, then you perform the transformation, right? Unless transformation will not trigger when the action is not called. So this is not a difference. This is just like a dependency. Like I say, transformation has dependency on action. When you don't call action, your transformation will not be come in execution, right? So this is a dependency. Difference means if I say the transformation is always converting one form to another form. Okay, So one transformation you apply, you can get RDD, and then again you can apply the another transformation. So you have option to apply multiple transformations, right? But when you apply action, you can't do further transformation. You can't do. Have you seen that whenever you do count, whenever you do for each, whenever you do collect, after that, can you apply transformation on that result? No,
No.
right? So that's the difference. Okay. One is giving conversion, right? Like one transformation to another transformation you can trigger, right? When we create a RDD and when we do transformation, when we create another new RDD, we will create. But in case of action, there will be no further transformation we can do. It's a final result, it's an end result, okay? So that means we are performing action. So when we perform action means you can't do further any transformation. That's action, okay? So action lazy or this one, both are lazy, or like it's the concept, main concept in action and transformation is transformation will not be triggered unless the action will not be called, right? Otherwise, this is just lazy. That is the reason transformations are called lazy, right? Can anyone tell Spark architecture, right? High level architecture, what I discussed, like if the driver program is submitted job, right? So what happens next? High level architecture, right? If I show you Spark architecture diagram, so can you see this diagram and speak about?
Yeah, so the driver is, so Spark is based on the master slave architecture, right? So the driver will assign the work to executors. The executors are the slaves, and the
Directly driver
driver.
can assign to the executor. Can you see flow? You can see, right? First, it is making a connection, right? First, it is having a session, right? Spark session, and through Spark session, it is entry point. It is getting an entry point to the cluster and assigning the task to the cluster manager. Cluster manager is the centralized part of your architecture. Okay, so cluster manager is allocating the task to the executor or getting the result from the executors, right? And then returning back. Okay, so the first establishment is done by through the cluster manager. Okay, then finally then once cluster manager established, then it can be like a Spark session can be connected with the executors. Okay, so cluster manager has important role here because it is allocation the task and getting the result from the worker node, and each worker having the task and execution of task is done. Then it is stored in the cache for the further processing, right? And once it's done, then it will be final result will be returned to the driver. Okay, so driver is a starting point of your program, which is having a main function. So you can have a main function in Python code, Scala code, Java code. So you are starting your program from the main function.
Yeah, I was reading this book as well. It's a beginning of Apache Spark. I think there was also one type of the work happens where it doesn't have to touch the cluster manager, just the driver and execute. I'll find and put in a group. But I thought I saw somewhere, it doesn't have to always go through the cluster manager all the time. Maybe that's why there's the upper arrow is there.
Yeah, initially, right, because default cluster manager is the local. Okay, whenever you are not using the Hadoop, right? So your cluster manager is Hadoop. Suppose you say, I want to read the data from the Hadoop file system. So your local cluster manager will not work, right? In that case, you will define the property. If you have seen minus minus master yarn you get. If you don't give this master yarn, you can't read the data from the Hadoop file system. There is no. So this master means this is a cluster manager only. This yarn is a cluster manager. So master means you are defining which cluster manager you want to connect. So if you are not giving this master yarn, it is taking from the local only. Okay. So master yarn is giving, then only it will understand whatever file path you are giving, this file path you are giving /user/test. So this is a Hadoop path. Otherwise, it will say file not found. If you try the local file path you give file :/. That's the reason you give file :/. This one you give, right? Why you give this? Because it should search in the local. But if you are using master yarn, So it will understand this path is a Hadoop path. So it's like an indication to your program which cluster manager you are using, right? Accordingly, it will start reading and writing data. Okay. Otherwise, it will always understand the local path. Okay, understand local path. Okay, let me start Kafka. Okay, basic introduction of the Kafka. Okay, then I will show you the Kafka. First, I'm going to start. What is Kafka message broker? So I think some people already know, but I'm repeating again. Okay, so Kafka. Okay, so Spark having a total mostly right 5 modules, but we are concentrating only 3 modules. So Spark core, which is completely transformations and actions, which is a core module, transformations and actions. Okay. Next we come to the Spark SQL module. It is basically an integration module. It is integration module, an integration module with the different sources and targets of the data. Sources and targets of data store. Okay. So we have some sources like file system sources, SQL databases sources, any source can be there, or REST API sources. So when I say data sources means the data is coming from the source and we are writing the data to the some target after the transformations. Okay. The Spark SQL module is like batch module, the batch process. The file system sources. The file system sources mostly file system data, right? CSV, JSON, XML, Parquet, Avro, ORC. So all file format we seen in the Hive, all file format are supported in the Spark. Okay, JSON, XML, Parquet, ORC, Avro. Okay, so these are all file formats. Next is the SQL data sources, SQL databases sources. So SQL databases sources, any MySQL, any SQL database, MySQL, Oracle. So we already seen this kind of data sources integration. NoSQL data sources, we already seen the Cassandra and Mongo and Elasticsearch. So Elasticsearch is pending. Okay, Cassandra, Mongo, DB, and Elasticsearch. These are the NoSQL data sources. Okay. Now next comes Spark streaming module. So we say Spark support batch and real-time both, right? But MapReduce is supporting only batch processing. Okay. But Spark supports batch and real-time both. So when we say Spark streaming, it is completely real-time streaming, right? When the data is coming from the streaming sources. So what are the streaming sources? Like I say, Kafka is a one streaming sources, or we can say we have social media websites, right? Social media websites, Twitter. So Twitter is getting the hashtags handles, right? So those streaming data I'm getting through Twitter, Kafka, and REST API. So some REST API services are there. Those are exposed, like weather department REST APIs is there. So they are sending the streaming kind of data, or we can say some live ticket streaming matches, right? So those kind of websites, those kind of REST APIs exposed, and we have to consume the data from those APIs. So mostly these data we are getting JSON data. Okay, JSON data we are getting. Okay, so JSON data is a key colon value format, right? So we have the JSON data. So when we are working in the Spark streaming, so we have to understand what is Kafka here, right? Because Kafka and one is a socket also streaming source. Socket is like a network connection. So I'm connecting some network and getting the data from the sockets. Okay. So socket connection is also one streaming source. Okay. So when we come to the Kafka, so Kafka is a message broker tool. Okay. If we say any other broker tool, message broker tool, there are many other message broker tool are there. ActiveMQ is there. ActiveMQ, RabbitMQ. Okay. And like some IBM data, some IBM MQ is there. So there are many different message broker tools are there. If we talk about in the cloud, so cloud we have in the AWS cloud, we have Kinesis. So Kinesis stream is the like message broker, right? Which is producer consumer. So what is the architecture of the Kafka? So there is a producer is there. Okay. consumer is there, and broker is there. And zookeeper is another component which is keeping the high availability, between the brokers, right? And zookeeper is a coordination service. So zookeeper is a common tool which is used in the HBase also for the high availability and like master server and region server high availability. So coordination between the services. Okay. So if I say here, what is producer? The producer is in Kafka, which is producing the messages for and writing to the Kafka topic. So Kafka is push and pull mechanism. Kafka is a push and pull mechanism. And who is pushing the data? Producer is pushing the data, pushing the messages, okay? And consumer is pulling the messages. Okay? Consumer is pulling the messages from broker. So where it is pushing the messages to broker. Okay. And the consumer is pulling the messages from broker. So that is the reason it is called push and pull. So broker is a server. Broker is called in Kafka is a Kafka server. Whenever Kafka server is called, that is means broker. That is intermediate component of producer and consumer, which is acting like a storage. Okay. It is storing messages temporarily. Okay. It's storing messages temporarily. So we can say the default is a 7 days is there, 168 hours is the default retention period is there, 168 hours retention period. That is a default, but you can increase or decrease this retention period. What is this retention period? Retention period is how long your message can be stored if this message is not consumed by the consumer. So it will be stored for the 168 hours, 7 days. So 7 days is the retention period or the messages in the Kafka server. Okay. And these messages are stored in the log files. The log files, you can see these log files in the Kafka server, and these log files having storage of the messages. Okay. Next thing comes in the Kafka server is topic. What is topic? So Kafka server is a machine. Kafka server is nothing but is a machine. We are saying this is the broker. Okay. But actual thing in the Kafka server is topic. What is topic? Topic is a category of messages storing. A category of messages storing. Okay. So that is basically a topic. So if I say how many topics I can get, multiple topics you can create. So suppose I say I'm getting a one payroll related messages. So payroll related messages I will be sending will be sent to payroll topic. Okay. So payroll topic is there. So we can create a message. What is the purpose of creating topic? The different topics. So our messages should not be mixed, right? If I'm sending my message for the payroll department, so payroll department will be reading the messages from the payroll topic. And who is sending the payroll messages? Some source system will be sending the messages to the payroll topic. So there is a proper designation is there, right? This particular message will go to this particular topic, and consumer will be receiving the topic, receiving the message from the particular topic. So whenever producer is sending, it will be sending to particular topic, any topic, okay, any topic, whatever topic you specify. I will show you this communication, producer and consumer communication through command line and through programmatic way. 2 ways we can do this communication. Okay, so sending to particular any topic, and consumer is basically receiving messages from particular topic. Okay, so topic is basically a kind of category of messages stored. Okay, that is topic. Further in the topic, like we say, the multiple partitions are there. What is the use of these partitions in the topic? Because topic can be divided into the partitions, like data can be sent or received parallelly. So it is used, the partitions are used, right? Partitions in topic are used for parallelism. Okay, because I want to send or receive the data parallelly, I will be using the partition. So I can say like I'm sending the message to the this particular topic. So if I have defined the partitions also, I can send to the partitions as well, right? Particular partition. Same way, consumer can receive messages, receive messages parallel from the partition, multiple partitions parallelly. Okay. So this is the use of the partitions. So in the Kafka, when we are using partition, so in the consumer side, there is a component is there, consumer group. What is a consumer group? Consumer group is set of consumers. A set of consumers are defined in the consumer group, a set of consumers. And these consumers will be receiving messages parallelly, will be receiving messages parallelly, okay, from partitions in the topic, partitions in the topic. Okay. So this is consumer group. So these are the main components we talk about. Like there is a producer, consumer, broker, topic, partitions, and zookeeper. Okay. So these are high level architecture components. Okay. So first we start like what we have to do. Kafka is written in Scala. Okay. Like same like Kafka is written in Scala, same Spark is written in Scala. Kafka written in Scala, okay, and same as Spark. So we use Kafka. First, we have to download the Kafka. Okay, so Kafka, we have to download Kafka release. Okay, so we go to the when we see here Kafka download. Download. So latest version 3.5 or something. So we have to check which Scala version you are going to download, because if your Spark Scala right 2.12, so use the Kafka 2.12 one. Okay. If you are using a Spark 2.13 Scala version, so use the Kafka also 2.30. So both versions they have given, both binaries they given. So we download 3.5 one. Okay, 3.5 release one. So we download the Kafka 2.12 3.5 0 TGZ5. Okay. So first of all, what I need to do, it's very simple. Like other installation you have done, right? You have to download the zip and extract it and then set the home path. Okay. So I'm showing you mine is Kafka is already installed. I'm showing you the installation. After we have to understand producer and consumer APIs also. We can write a producer consumer API code in the Java, Scala, Python. So all three languages are supported here. And if I want to test the producer and consumer, I can test through. I can test through the. I can test through the. That one also. I can test through the command. Here is some memory issue. Okay, I'm showing you. So here in the I have downloaded Kafka and I copied the Kafka, extract the tar file and extracted the tar file. Okay, 2.12, 3.5. And next is dash RC file. Dash RC file, you have to set the Kafka home and Kafka bin. You have to set. So once you set this Kafka home and Kafka bin part and use the source command and now we have to start the Kafka service. So Kafka has one producer service, consumer service, and broker service. Okay. So when I want to do communication between the producer to broker and broker to consumer, okay. So I have to start the services. Okay. So if you want to see the command, so you go to Kafka quick start. Just I'm changing the white. So here, so this part we already done. We have downloaded Kafka. So we have to start the zookeeper first. Okay. So I have to start the zookeeper. So I will start the zookeeper service. So I have to go to first in the Kafka. Next tab I will open. So here I will start my server. Okay, this is my Kafka server. In the bin, there is a Kafka server.sh, and it is using the server.property. It is using server.property. So I'm starting here Kafka server. Kafka server. Kafka server we are starting and giving the property is a conf. Okay. So next step I will be starting the producer, because producer is sending the message to the Kafka server. So producer is, but before creating a starting the producer, we have to create a topic. So I'm going to create a topic. So Kafka topic.sh command will be creating a topic. So I will give a topic name, which topic I want to create, and bootstrap server your Kafka server. So Kafka is running default port 9092. So 9092 port is a default port for the Kafka. Okay. So we can create a topic. So once the topic is created, if this topic is already created, then it will give the error message topic already exists. Okay. Topic was not already present. So the new topic was created. Once the topic is created, I can see describe command to see the topic also, right? We can see the topic more detail, right? How many partitions, default application. So those information I can see about the topic. So I will run this command. So it will be giving the information about the, so partition is 0, only one partition is there. So partition 0 is there. Leader is a 0. So in Kafka, there is a leader and follower concept is there. So what is the leader and follower concept? So leader is basically in the broker, like if it is multi-broker system, if it is a one broker is there, if only one broker, right? If one broker, so this broker is leader as well as follower and follower. So there is no, like if this broker is down, so you cannot send the messages, right? Because this leader is the follower itself, right? So this machine is down, this broker machine. So then you cannot send the message to the your Kafka broker. So the other scenario, what we do, we use the multi-broker system. So multi-broker system where one broker is acting as a leader. So one broker is acting as leader, and other brokers are followers. Brokers are followers. Okay, and when one broker is down, when this broker is down, so one of the follower will become leader. So this is the main concept behind multi-broker system. But in this case, our one single machine we are using, right? We are not using. So sometimes in the one machine also we can create a multi-broker system. If you want to test, we can create a multi-broker system on the same machine by creating a multiple server.property. So what we need to do, this server.property file. So we can create a 3 server.property file. So server.property, server1.property. We just make a replica of the server property. So this server property file is in the config folder. Okay. So we create this server.properties 3 replicas, and one replica will be running. So there is a broker ID is there. Every broker is recognized by ID. And this broker ID, if you see the config file, let me show you the config file. If you go to the config folder, here, if you see server.property. So this server.property is a broker property file. In this broker.property file, you will see every broker is initialized by one ID. So default is ID 0 because only one server.property is there. But when you are creating a multi-broker system, like you want to test your multi-broker system on a same machine, so 3 server property we create, and we create a different server.property, different broker ID. Like one broker ID is 0 for one server.property, second server.property broker ID 1, broker ID 2. And we change the port. The default port is 9092. That is the port for the default server.property. But suppose if I'm creating a multi-broker system, in that case, I will create this broker ID, I will give 0, and port I will give broker ID 0, and port I gave port already there 909. But when I'm creating a server 1.property, so I will give broker ID 1 and port 909, so that we can have a different port and different broker ID. Okay, and this server.property I will give broker ID 2 and port 9094. So like this, I will give the different port. So when I start the multi-broker system, so what I need to do? So when I start the server, so I will be using the this server I started, right? So which command I started server? So just you use the different 3 terminals you will use for the 3 different server.properties. So 3 different server.properties you will start. So you will give Kafka server start.sh config/server 1.property, server 2.property. So this way you can do the multi-broker system. So when you check, your topic will have multiple partitions, one leader will be there and other will be follower. Okay. And what is the ISR? ISR is the concept of in-sync replica. So generally this is used when you are having leader and follower concept. So leader and follower, because multi-broker system is there, your leader and follower both are synced to each other. So how leader can sync with follower and follower sync with the leader? So there is a in-sync replica is there. In-sync replica is, it's like a same copy of the data is present in the leader, the same copy of the data will be present in the follower. So any point of time your leader is down, your follower will become leader, so follower will have the same information. So your messages will not be you will be able to handle your messages. So if one broker is down, another broker will become leader, and the follower will become leader, and then it will hand. So ISR is a in-sync replica. In-sync replica, that is basically syncing the data, right? The broker is keeping the messages and data, right? So those information, whatever in the leader 1, the information same is synced to the other follower also. So data is syncing between multiple brokers. Okay. So multiple brokers. So this concept of partitions and leader, replicas, ISR, these are come into the picture when you are using multi-broker system. So if you describe the topic, so you will see the by default application factor is 1 because it's only one copy, right? And one machine, right? So there is no multi-broker system. So that is the reason it is showing this all other things 0, 0, 0. Okay. So this is my topic. Next is I have to start the producer. So producer is sending the messages. So console producer command is there, Kafka console producer.sh, and I have to tell which topic I want to send the message. So I'm telling the topic name and the server, because if you give topic name, if you don't give the server, it will not be able to send the message. So you have to tell which server, which broker, and which topic, because one broker can have multiple topics also. So topic is very, very important, and broker is also important because both the properties need to be given, right? Only broker you give, it will not be able to send the message because topic is also required. If you are giving topic only, so bootstrap server is also given, right? So both things you have to give, and it will be sending the messages, and then you can send the message. You can type the messages. Okay, so when you start now here, so these messages will be received by the consumer, right? But I haven't started consumer. So where these messages are going? These messages are going to the broker. So if I go to the broker, I see the server log. So there is a logs folder is there. So there are actual messages are stored. Okay. So that setting is like what I have set it in my, if I check it, what I have set it for the path. So if I have, by default the path is temp location. If I have not set the temp location, if I have given my Kafka directory location, so I have to check the message over here. Okay. So here in the config property file, let's see what is the logs location. So if I see this TMP Kafka log is the location for the log DIR. So this location I will find my messages. Okay. So if I check my messages, I have to go to inside this directory. I do here. If you can see, one topic folder is created. So this folder topic is just created now. So if I go to this one, CD, quick start, and if I see here, I can check the messages. So here is log file. So this log file is storing your message. If I cat command this one, yeah. So here is the encrypted message there. So far I sent this message, right? So your message is temporarily stored in the Kafka logs, right? So Kafka server log file, it is stored. Now I'm going to start my consumer. Okay. So now I'm going to start my consumer. So Kafka console consumer is there. So Kafka console consumer, which is also reading the data from some topic, and I'm giving a property here from beginning. So there are two properties are there, from beginning or latest, right? If you are giving latest means only the latest messages will come. But from beginning means when your consumer will start, it will read from the beginning. Okay. So whatever messages are not received by the consumer yet, so that those messages will be received by the consumer. So I will start another terminal. Here I can start so that I can compare the messages. So here I'm starting the same topic I'm giving, and I'm starting my console consumer. So you can see here the messages are coming. Now if I message, okay, if I check here messages, so messages are coming, right? So this is the way of like receiving and producing the messages. So these messages are coming through the broker. So broker is the intermediate server which is handling the messages. So here we are just sending the messages and receiving messages. But if I want to do some manipulation, so that also I can do. There is a Kafka streaming module is there. So Kafka streaming module, we can manipulate the messages and send to the, so we can write a code for that. Okay. So one more thing is, this is the command line way. Generally, this particular way we use while testing. Like I want to check my producer, server, and consumer all are working fine. Command line, I will be checking through command line. But mostly we use the programmatic way. So when we are using a Kafka Spark streaming, right? So that is the programmatic way. So we have to write a Kafka Spark streaming code programmatic. Okay. So if I say this producer and consumers can be used programmatically also. So how to use programmatically? We have to use a Python Kafka connector. So one Python Kafka connector we need to install if we are writing a Python code. If we are writing a Java code, we have to use a Java project, right? We have to create some project in IntelliJ, and there we have to use a Kafka client jar, and then we can write a program for the producer and consumer. So you will see when you're writing a program in Java classes, and when you're sending message from the producer, the consumer will be receiving the message. There are the Java Spring Boot applications also there, like there is a Kafka template. So Kafka template is a way to send the messages to the Spring Boot. So Kafka template basically is used in the Spring Boot application in microservices. So a Spring Boot application use the Kafka template, the programmatic way to send the message from the producer to consumer. But when we are using like Python, so we have to use the Python Kafka connector. So Python Kafka connector need to install, right? First we need to install the Python Kafka connector, and then we can send the message programmatically. So programmatic message, the advantage is like it can be sent dynamically, right? We can reuse the code and we can write a producer and consumer code for any source or target, right? We can define. So we have to install Python Kafka Connect. So that is basically we have to do pip install. Okay. So if I have already installed, so it will be giving me it is up to date. Okay. So I will be installing this pip install module. So this is already saying the dependency is satisfied. So first of all, you have to download this Python class. And next thing is once this is installed, this then we can write a producer code. So producer code. So for producer code, we have to, this is a command line. So I have to write a Python code. So first I have installed the Kafka Python, and then I'm writing a Python code. So we have the from Kafka import Kafka producer. Okay, and we are creating a producer object. So how to create a producer object? We are creating a producer object by using the Kafka producer class, and bootstrap server I'm giving localhost 9092 and producer.send. So producer.send, this is the topic name. So this topic, if it is not there, we have to create topic, or we can give our own topic, whatever topic we have. And this is the message, right? Some message I want to send. So I'm sending the message and I want to print, and I can use the command line consumer to check the message or programmatic consumer. So whatever message, whatever way you want to do, you can do. Either you can write this Python code. This is Kafka producer code. This code we can run in the Python shell. Okay, so here first we okay, so our topic name we have to change here. We will change our topic name to quick start event. So this topic already I have. This topic I will change. So send method is basically a programmatic way to send the message to the this is because of indentation. Let's catch it there. Try and accept is if any error message comes. So this is using try it. Okay, and this is the return whether your message is sent to the offset number is. So one more thing is there in the topic, like there is the offset. So offset is basically maintaining the sequence number. So when you are sending the messages, right? So the message will be followed some order, and that order will be receiving the message in the same order. So that is maintained through the sequence number, and that sequence number is called the offset. Okay. So this is the topic name, and it is showing the partition, and offset is showing. So offset is basically the position. So whatever position your message is, like 1, 2, 3, 4, 5, 6, 7, 8, 9. So you will be defining the position, right? So here you can see my consumer is already running. So I'm able to see my data, right? So I have how many times I'm doing. So I will be sending the message. So again, I want to send the message. So I can send the message. So, but if I want to read the message to programmatic consumer. So programmatic consumer, how to read the message? So programmatic way, you have to define the consumer class. Okay. So we have to define the consumer class. So we have to write the code for the Kafka consumer. So we will be importing the, and here is my say top. But Java, we have to write a complete code. We have to write a program like main function program. So two programs we have to write, one for the producer class and one for the consumer class. If you want to write in Scala, so you have to write an object there. So same thing if you are writing in the Scala, Python, or Java. So you have to write. So here we are writing a Python script. So here any group ID, localhost, same. So I will be creating a consumer instance. I will be generally doing the separate two terminal, but here I'm just testing the output. So here I'm reading set of messages in the consumer. So I'm reading one by one. This localhost 9092. Now it is able to get the instance. Okay. So now connection is established between the consumer and producer. Okay, consumer and the broker. Now I'm reading the each message in the consumer. Okay, so it will be printing the message with the key and value. So every message have one key and value. If you are not giving the key explicitly from your producer, so default key will be null. So only message you will receive. So whatever message you are sending, this message will be received as a value. Okay, so this is completing or not. Yeah, I'm getting this messages. So when I'm sending the programmatic producer, then I will get the producer and consumer. So key is coming null, right? So I told key is coming null. And this first one is the topic name is coming, then the partition is coming, then offset is coming. So every message is coming on the one offset number, right? Sequence. If you see, it is maintaining. Okay. Okay. So I'm sending messages from the producer. Yeah, this is the producer. So this message I'm sending. So here I'm getting. Okay, so this is the communication between the producer and consumer using a programmatic way. Okay, so you can write your on particular producer and consumer classes. You can write, and so we can these messages we are giving hard coded, but we can read the messages from the file also. We can read the file. So in Python code, we can read the file and send the message as a file, right? Once we file, we read, and then we can pass the messages to the producer consumer. Okay. Okay. Next thing is uh, like when we are going to start the Spark streaming, right? So Spark streaming, we need to understand how many types of streamings are there, right? So there are the two types of streaming, okay, in the Spark. So one is a D stream. So there is a one D stream, and one is structured streaming. So what is the difference between the D stream and structured streaming? D stream is like streaming of the sequence of the RDD. This is the sequence of RDD. Okay. So when the RDD is coming consecutively, so you are having a D stream. Okay. So discrete stream. Okay. And structured streaming is a sequence of the data frame. So we know, right, in the batch processing model, we have RDDs and we have data frame. So when we say D stream is a sequence of RDD and structured streaming is a sequence of data frame. So when the data frames coming continuously, one after one, that is basically structured streaming. So in the streaming, we have a concept of batch interval and sliding intervals. Okay. So batch interval and another one, the sliding window. Okay. So what is these two things are there? So batch interval is like one batch to another batch, how much time interval is there? Suppose I say one batch, like if I say 3-second time is there. Okay. And how much is your window time? Okay. Or I say one batch to another batch, I have a 1 second, and sliding window is a 3 second. So like 3 second sliding window, how many batch will be covered? 3 batches will cover. Okay. So if my sliding window is, I'm saying one sliding window is like one batch, right? So basically the 3 second is my sliding window. So I will cover the 3 batches. Okay. So this time interval I will define when I will be writing a Spark streaming code. So Spark streaming is basically, Spark Kafka streaming is a consumer code. It's not a producer code. It's a consuming code. It's a consumer code. So instead of writing this program, right, this consumer program, we write a Spark streaming code. So either we write a Spark streaming code by using we can use like RDDs, stream, or structured stream. So structured streaming is more easy to handle because it's like a data frame transformations and the join, group by aggregations we can do. And when we are writing the data to any target data store, so we can write into the batch. Okay. So there is a for each batches we have to write, because streaming data will be writing continuously to the any SQL databases or file system, right? You can create a multiple files. So there is a for each batch. So whenever the batches, the data is coming, you are continuously writing data, continuously writing data to the files, or it could be to SQL database, like any SQL database you can write, like MySQL or Oracle, or NoSQL database like the Syndrome. So streaming target can be anything. Okay. And source, you can read, even you can read the data from the file system source also. Okay. So file system source also are one streaming source. How? Because suppose you are giving some folder location, some directory location you are giving, and directory location, and this directory location you are putting the file continuously, putting the files continuously. When you are file continuously putting the file, it will be keep reading those files, and then you are writing the data to the target. So files also are streaming. So, and one more difference in the D stream, like D stream is not maintaining the delayed event, not maintaining delayed event, not able to handle properly, not able to handle delayed event. What are delayed event? Sometimes messages are getting delayed. Some messages are getting delayed. Messages are getting delayed. Okay. So those messages will be lost. Those messages will be lost. Okay. Because it's a synchronization, like it's a synchronous messaging. Okay. So those messages will be lost. In that case, structured streaming is giving a concept watermark. So if you heard about watermarking, so watermarking is one threshold window. So watermarking is time threshold, and this time threshold is basically I can say like 2 minute window or like 3 minute, whatever time I want to give. It will wait for messages for delayed event. Wait for delayed messages. Okay. So that is the reason structured streaming is more powerful than the D stream. And one more thing in the difference in the D stream and structured streaming, D stream has separate their APIs functions are there for different source. If you are reading data from the file, so there is a file as stream source is there. There is a method is there, file as a stream. And if you are reading from the socket as a stream is there, socket as a stream. If you are reading data from the Kafka, so Kafka util dot create stream function is there. Kafka util class dot create stream. Okay. So you have to remember all different APIs function for different sources. But here in the D structured streaming, the advantage is you don't need to remember the specific function. You have to remember the format. You should know the format. If you know the format is a file, so if you say there is a spark dot read stream, So there is a unified one single method, but before that you will be saying spark dot format, and you are saying format is a Kafka, or format is a socket, or format is a file. So just you tell about your format type and then call read stream function. And read stream function again, you will be providing your options. So you will be giving the different options are there. Suppose you are reading the data from the Kafka. So definitely you need a broker ID, address, and topic. Two things you need, right? And the topic option is a topic. So two options you have to provide. If you are reading data from the socket connection, so you will be like a network host, right, from where you are reading the message. And if you are reading the file, so you have to give the file location. So in the Spark structured streaming is basically handling the delayed event, and there are the three different types of mode are there. So one mode is the insert mode, okay, complete mode, and update mode. So there is a, like I can say, like stateless and stateful. Okay. So when I say just I have to do, if my batches are coming, I have to just insert the data or update the data. Okay. But complete mode is basically the combination of insert and update. Okay. So it is basically, if the record is new, it will insert. If it is existing, it will do update. So suppose if I want to do word count in the streaming, so like I'm sending the messages in my network, or I'm sending the message to Kafka, and I want to find the word count, right? If hello is coming first time, so it should be a hello comma 1. Again hello came, so this hello and hello again second time, so it will become hello comma 2, right? So I should keep incrementing my count, right? So that I will use the complete mode. So I want to retain my previous request messages to the current. Okay. So there are the three different mode are there: insert, complete, update. So we can use it. Okay. So structured streaming is completely on the data frame, right? And dstream is the, and one more thing is this structured streaming and dstream both are supporting, that is checkpoint. So checkpointing is very important concept. Checkpointing is sometimes your server is down and you are not able to receive the messages, right? So in that case, your streaming, Kafka Spark streaming will store messages in some buffer area. So some buffer area, we can say in case of Hadoop file system, SDFS. So SDFS, some directory will be created. So some directory where your messages will be stored, okay, as a checkpointing directory. So some directory that is called checkpointing directory. Okay. If we are using AWS, so S3 will be a file system will be used for the checkpointing directory. So S3 will be used as checkpointing directory. So these are the different like ways we can store the messages. And when the server is up, right, after your crash, okay, or you server gone down, then again you up, then you will start receiving the message from the older messages you will get it from this checkpointing directory. So there is a two types of checkpointing: metadata and data checkpointing. Okay. So metadata is storing the metadata about the data, and the data checkpointing is actual data, right? So two checkpointing is there. Metadata is storing messages, metadata of messages, okay, data or data, and data checkpointing is storing the actual data, okay, because it will be keep tracking of your messages, right? Like how many messages are stored in the checkpointing directory. So data checkpointing is storing actual data. So your message will not be lost in case of using the. So checkpointing is supported by both, right? Because even you are using Kafka streaming or Spark streaming. Okay. Okay. So more this is just high level theory. I just talk about. You can see the documentation of the Spark, right? There is a website documentation of the official document of the Spark. So there you can see these many concepts. Like, okay. So if practically, if you want to start, we have to, okay, so we are starting like Kafka one. So we have to use the Kafka connector, whenever we are using Mongo, Cassandra. So for that Kafka also we need a connector. Okay. So we need to start the connector. Let me ping the connector so then I will. We start PySpark scripting. This is Spark Scala one. Okay. Let me show you the through Spark Scala because the code wise nothing different. I will give the code of the PySpark also. Okay, because function is same, right? Read stream function. So you can see first is I'm starting my Spark shell. We can run the program through the Spark Submit or we can run the program through the shell. can check here what is the latest version of the connect. If we go back, this is the version wise is coming. This is a 2.11 Scala version, so we have to 2.12 Scala and the Spark 3.x. So we have two point 12 and 3.1.3. Vice versa. Times no, we should not use this double quote. Issue is a problem in the double quote. Okay, so don't use double quote because anytime it will not start. Even any version you give, it will be giving issue. Okay. So I just recalled that the double quote we should not give. Without double quote, you give the package, then it will be able to find. Now you see there is no error, and I'm able to start my Kafka Spark. Okay. So with the connector, PySpark connector, I'm able to start. So now what next I have to do? I need to use this double quote. Okay, so this double quote is the issue. Next I have to, once I start the shell, I have to get the messages from the. So I'm showing first example of the streaming one, this structured streaming one. Okay. So in the structured streaming, we use the read stream function. So how to read the data? So this is the one import state. Says I'm going to read the message from the particular topic. So my topic is saying quick start event, and here is beginning or earliest. Earliest is the latest one, and beginning is from starting. So I'm giving my read stream format is a Kafka. If I'm reading data from the socket, I will use the socket here. So I will get the message from the socket. So I will be reading the data. Okay. So when I do print schema, it will be showing me my data frame. But this data frame, you can't, your these many columns will come in your data frame. But this data frame dot show you can't do here. So you have to write the data frame on the console. So once you start writing this console and start await termination, then automatically it will start every time it will display. Okay, you don't need to do, but before that you have to use the casting because generally the message is coming as a byte. Okay, but if you don't want the get message as a byte, you want to cast it as a string. So your key and value, you are making it as a cast as a string. Okay, so you are using a select expression and changing your value and key. So there are the many columns are there, but you are trying to select only 4 columns: partition, offset, and topic and key and value. Okay, the topic I don't want to display. Okay, because I know from which topic I'm going to get the data. And this will, if you try, I let me show you the error. If you take this one and do show function, what error will get? So you will not be able to do like a batch processing, you can't do like show function. So it will be giving you error and it will be saying write it on some queries with the streaming sources must be executed with the write stream start. So write stream start only can get the messages. Okay, so you can't do there. So I will start my streaming now, and this streaming will continuously keep running. And whenever any message is coming, it will be keep reading. Okay. Right now, I have to start any producer also because there is no producer which is sending the message. So I start the producer so that I can see my messages. So I will start one producer. Topic already there. Just I'm starting my console producer. So this console producer will be sending the message. Okay. So, so now I send the messages. Okay, so there is some error is coming. Quick start event leader not available. Like I broker is down. So we have to check. This is my zookeeper. Second one is a broker. Broker ID 0. Now I start my consumer. Okay, output mode I should not use. Is illegal argument exception dot beginning. Earliest is okay. So now I'm able to see my messages, right? Partition is all messages on the partition, and offset is a sequence number, and key is null because there is no key is passed. So I'm going to receive my messages. So this is the batch 0, okay? And I'm giving like another message. So I get the batch 1, and then how are you? So these are the messages I'm getting, okay? So if I want to do word count on this program, okay, so I have to do the transformation because this time I'm just going to show you just simply messages, right? I'm getting the messages from my server and I'm getting messages. I'm consuming the message in the consumer. So in the consumer, I'm just consuming the messages. So I'm not doing any transformations on this data frame. Like if I'm going to do any transformation, then I can do the word count on that. So for making a word count, I have to so if I want to do word count on the streaming matches count. So simply this part I've done, right? Read string. And after that, I'm printing the schema I'm getting, right? So this is, and then I'm just doing the select expression. So like I'm getting this is for JSON messages, okay? But it will be converted into the data frame. And now once we have data frame, we are like writing it. So one thing is we have to use output mode complete, but before that, we have to use like math, flat math, and like I want to use the non-empty related things. So I want to do, otherwise I can do group by, and then I can do the count function. So, so I can, in my data frame, like if my data frame is this data, right? This, so I will apply the word count on that. What is this? Word count is a place. Okay, this is calling some function, clean data. So clean data is a function they are calling. But if I want to simply map, I can use the lambda, I can use. So getting the data in this value column. So my value column, code have to do it because have to start again the streaming. All statement. Whatever transformation we want to do, we should do it before writing. We'll take it only one column where we want to do the what count. So I will now this df1. Now I will be writing to the write stream. The write stream I will use output mode is a complete mode. So after this, I have to use this line of the statement. Now df1, we are writing console output mode is complete. Await termination means it will wait for your termination, then only stream will stop. Otherwise, stream will keep running. So now I started stream, and now to send a message. See, it is reflecting, right? Initially, like U is one, how is one, I is one, I is seven, some blank is there, right? So it is now this streaming is keep running. You just send I'm fine. Every time your message will be keep coming, right? It is so this code will be you will be same thing we can do the socket. Okay. So I will show tomorrow, Monday, I will show the streaming one, right? With the socket connections, right? How to read data from the file also, because this is we have seen with the Kafka. So how to do Kafka as a stateless and stateful. So a stateless example is when I'm not doing the any output mode complete. I'm using output mode complete. That is my stateful. The stateless is like either append or insert mode. That is a default mode. Okay, insert is a default mode. So I can use the stateless. Just I'm getting the message and printing the message. So in that case, you have to just simply write the streaming. So I'll just make it the code for that also, so that you can either use can this one. This code is for stateless. So like stateless software streaming. and stateful, like you are doing some word count. So these are the stateful. You will not get all the columns, only the value column you need. So I'm just removing other columns, and here also I'm not taking it off. Okay, and before starting your streaming, before starting the stream, I have to do the split by and group by count. So I have to apply this split by on this and get the df1, and df1 is my write stream I will write on the console. So here I'm writing the data on console, but we can write in the DB, any SQL database or NoSQL database we can write. Okay, we can write output mode complete. Okay, so here is no need of output mode. We are simply okay. So this is so these are the two examples you can try. One example with the stateful and one is a stateless. Okay, so this code I will just okay. Okay, so tomorrow I will show the more in the streaming like socket connection and how to read the files as well. Okay, but the transformation option that will be the same. So this will be same for everyone because we are getting as a data frame once, then we do the transformation logic will be the same. And if I'm going to write to the not to the file, if I'm writing to the if not to the console, so I can write to the file and any SQL or NoSQL. Okay. Okay, so anyone has any question? I'll share the recording and you can start first doing Kafka practice and do setup of Kafka and then do the Kafka connection through the command line and programmatic way and then try Spark streaming. Okay, and the watermarking and that I will also show, right, how to use the watermarking and the checkpointing. So how we can add the checkpointing directly and the watermarking time threshold so that we can make it our structured streaming. And these stream also we can use streaming with Kafka as well, like Kafka and socket, like same whatever example we can do with the structured streaming, same we can do with the these. Okay, first you guys do practice. If any question is there, let me.